That was exciting. Make sure the sound is still working. Yep, we're good. Okay, cool. All right. We're trying to find a right half horizontal asymptote. Very first thing you should write on your paper is we need to find a limit. As x approaches positive infinity of the function f.
Wait, why did we choose positive this time?
Because this time they specified right half.
Oh, sorry.
So good question. No, keep asking. Hey, the thing I'm trying to impress upon everybody's mind is this. Calculus has to be interactive. And it's true of anything that's, really anything you learn, if you really want to understand it, you have to interact with the teacher. Like you can't just listen. Like I love YouTube, but I hate that I can't ask questions. Like I get stuck. Like one of my things I do on my own time is I try to help all my married kids with all their cars. Like I do my best to help them with repairs and things, and I like learning about it. And I hate when a video will say, do this, and they don't tell me why. If I know why, then I have so much more power. I'm rambling now. Okay, moving on. So don't forget the equal sign, always lose points. We good here?
First one?
Even on the first one.
Ah! How many noticed that mistake? 3 points. Take 4. Mark down 5. Okay. I kid you not. Mark 5. I hate when I do that. Yeah, there's no equal to start with. It's not equal to anything. We're finding the limit. Okay? We good?
Right,
Yeah.
5.
Awesome. 5 is good though. Stop at 5. Okay, now we put an equal sign. We're still finding the limit as x approaches infinity. We follow our flashcard. Number 1 definitely applies. So we've got to compare terms that add. Just say it as a chorus. How many? Oh, I don't know. I'm probably being way too detailed. Any questions about the fact that the numerator is composed of terms? How many are there? Say it. 2. So, as x gets more and more positive, the 2 and the 16 are irrelevant, but the x cubed will grow so much faster than the x squared. The only way to prove that to you, well, the easiest way to prove it would be just make another spreadsheet. I'm just asking you to trust me, please.
So when you write it down, you don't put the 2x cubed, you just put the x cubed?
You have to include the
You
2.
do have to.
That's a little confusing. When you're making the comparison, don't think of the 2. Just think of the exponents. But you can't throw the 2 away because it's not actually a term, it's a factor.
Okay.
Because here I have a thing times a thing, and I have no easy way to discard the 2. So on this line, I'm going to write 2x cubed. I save the dominant term. Raise your hand, please, if you can tell me the dominant term in the numerator. Hands up. You can tell me the dominant term in the denominator. Sorry, Sarah, what's the dominant? Dominant term in the denominator.
Negative 4x squared.
Super important that Sarah said negative. We are comparing the terms that are adding. So in the denominator, we are adding a 10x, and we're adding that to a negative 4x squared. You must keep the negative. How many new? 2 more, 3 for Sarah. Rich. Okay. Questions? Taylor, please.
Basically, you just pick whatever one gets the biggest.
As long as they're terms. As long as they're terms.
Okay.
Yeah. Warning. 1 second, Cassie. You cannot make this comparison if they're factors. Factors means you got thing times thing. You can't make the same comparison. It's not logical.
Then it'll be like more exponential.
It gets way more complicated. Like, here's how I think of it. If I have, I don't know, weight of the earth added to weight of an ant, it doesn't make much difference, right? As soon as you start multiplying, it's not so easy to compare, but adding's easy.
Right.
Yeah, Cassie.
This might be really dumb, but do you just do nothing with the x squared on the numerator?
Up here,
Yeah, because the x3 is bigger.
you really are, basically, you are making that comparison. You're saying that as x gets bigger and bigger, this is going to weigh so much more than this. But even though it weighs something, we can just keep, it doesn't really make enough difference to matter.
Okay.
It's a good question. And that does feel weird. Like, that's part of why calculus feels weird to people, because we just kind of throw it away. You can't just throw it away, but for the purposes of analyzing what happens as x gets bigger, we can ignore it. Question, 3 more.
It's kind of like it's getting so much bigger that like the term that you're discarding keeps getting smaller and smaller and smaller as compared to it, so that eventually you just discard it.
Listen close. Hey, sorry, I got way too excited to let him talk. The words Noah used, the key word he used was comparison. You're comparing. When x is 1 billion, negative 6x squared is going to seem very large. It's just not very large compared to 2x cubed. It's the comparison that's important. It's not the actual number. That's why we're not paying attention to it. Like I said, on a computer, the computer can't do it. It can't add them. When x gets really big, it doesn't have enough processing power to handle it. It just gives up. Like the computer ignores it. It just gets lost, okay, because of the comparison. Good questions. Awesome, cool. Taylor, we answered your question so far. Okay. Next step, factor. So we go like this. Say equal. Say limit. X approaching infinity. We have 2 divided by negative 4. We have x cubed. Oh, we're going to factor some more. We're going to go x squared over x squared. We're going to go x over x. Sorry, x over 1. I said that badly. So now we have. This is going to cause a cardiac arrest. Man, my stressful. This stupid thing won't work. 1 second, Cassie. We now have factors. Okay, we started with terms. We now have factors. With factors, the comparison becomes easy in this way. This set of factors, it doesn't matter how large x becomes. That's always going to equal 1. Let's go to Cassidy and Caleb.
Do you have like parentheses around anything?
That's what I was gonna
Oh,
ask too.
good question. How many had that question? Show me hands. 2 points, 3 for Caleb and Cassidy. When you write fractions, you don't have to. As long as you have them just right next to each other, the multiplication is implied, and they're fine with that.
So it doesn't matter whether or not you use
No, you'll see me do both because I don't even know why I do both. I just kind of go back and forth. Sometimes if there's a negative, I will put in some parentheses to make sure it's not confused with subtraction.
All right.
But as long as you have fraction times, you're fine to just list them out. Good question. Yep. Cool. So now we just plug in the number. We say if x were getting bigger and bigger and bigger, this would equal 1. This would be a negative 1/2, but this would grow forever positively. So now we don't even care about the negative 1/2. It's just growing forever. Positive times negative is negative. So that's the value of the limit.
Because of the negative 1.
Because of the negative 1/2 multiplier factor. Talk to me, you good? Just making sure. I tend to watch everyone's face just for any sort of,
So the only reason that it's going to infinity is that x is by itself, so just keep on multiplying.
That is correct. The x squared divided by the x squared, I don't like the word cancel. You may have noticed the sign up here. The reason I don't like the word is it doesn't convey any meaning. I prefer to say, these don't cancel. Like, something divided by itself is always 1. So 1 times anything is just whatever else. More for Jared. Birding it. We have reached the point where I need to start paying for naming penalties. Sorry about that. Well, you know. Okay, hold on. Okay, cool. All right. Good man. Help me, Lincoln.
I was just gonna say, for like the second rule, like, it says if we can factor, is there ever gonna be a time where we can't factor it out? Like,
Frequently.
Okay.
Yeah. It's one of their tricks. They get students thinking that they always have to factor, and then sure enough, they give a problem on an AP test that can't be factored. I tried my best to always be straightforward with you. I was fooled once. Like I was working an AP question that I'd never seen before, and I spent 5 minutes like trying to factor something that won't factor. Like dirty rats. Grace.
I just am confused on how you got the negative infinity again. Could you
No
explain
worries.
that again?
Yes. Are you comfortable with the yellow box?
Yeah,
So that makes sense to you.
yeah.
So try to see if this helps. Just think of plugging in like a million. Because that's what this means, that the X value is going to be maybe a million. You okay with that? Well, I have 3 fractions being multiplied. So I can think of them separately, temporarily. What's this fraction's value? Negative 1/2. I'm just going to write over here. That's being multiplied by this fraction's value. If you put in a million squared divided by a million squared, Grace, what's the result?
1.
Comfortable? So I'm plugging in a million, I get negative 1/2 times 1. And then I still have to multiply by another million that I plug in for the X. So a million here, that's 10 to the 6th. So ignore the numbers for a minute. If you have a negative times a positive, Grace, will the result be positive or negative? Smart. But it's going to be negative and big because I've got the million times the half. So that's 500,000. Did that set of computations feel good?
Yeah.
Perfect. And then all you think is, well, what if I plugged in 1 trillion? What would happen? The same computation, except this will become bigger, therefore this will become bigger.
Yeah.
Is that helping at all?
Yeah, that helps.
Is that better?
Actually, yeah.
Take 5, Grace. It's a really good question. Please.
So just so you have reason, like, so the reason that it's infinity is because it just, because the X can be anything, and the reason why for, like, X is going to infinity is because the asymptote is just also going to go on forever.
Correct.
Okay.
Yeah, you're memorizing this, Hannah. When they say, everybody, look, I guess your eyes on this one. Like, this has caused so much grief. You just have to memorize right now. When they say horizontal asymptote, you don't think of anything else other than, I'm going to find the limit as X approaches infinity. Just, that's it. Don't think of anything else, or negative infinity. Let's go here, Ellie.
So whenever there's like an X in the answer, it'll always just go on infinity.
Not necessarily. I would never want to say that. That could mislead you. In this case, I just did the computation. So I don't try to memorize any sort of rule like that. I just do what I did with Grace. I say, well, here's my formula. Let's just compute what happens. And I just take the result. Please, 2 more.
I understand how we got negative infinity, but I'm just confused on how an asymptote can be negative infinity.
Oh, gotcha. Let me throw up the graph that might help.
Okay.
Again, you're not going to be expected to graph this,
Right.
but seeing it will probably help you feel better about it. Is that okay?
Just y equals negative infinity, like what?
What does that mean?
Yeah.
Yeah, it's a good question. 2 more for Taylor. So here's problem number 2. I only got to 11, so hopefully nobody asks about it. Never mind, that's just a bad joke. Okay. Nobody even heard me. Okay. This is the graph of problem number 2. Okay? And what it's showing you is that as you pick an X value that is more and more positive, we just walk from one dot to the next. What are happening to the Y values, Taylor?
They're more negative.
Yeah, they just become more and more negative. And it doesn't matter how much we zoom out. Like if we go like this, come on. So we allow x to get bigger and bigger and bigger, the y just keeps going down. That's what this is telling you right here. That as x gets more and more positive, the y value is going to get more and more negative. So that's not a horizontal asymptote. The correct answer here would be, therefore, f of x does not have a right-hand horizontal asymptote. Better?
Yeah, so if it equals positive or negative infinity, it does not have that.
Correct.
Okay.
When you're finding the limit as x approaches infinity, if your result of the limit is a finite number,
Okay.
then you have a horizontal asymptote. That helps a little? Good work. 3 more, please.
I just had a question. I was just curious, going back to the problems that you can't factor,
Uh-huh.
does that mean are they just undefined or like?
We'll just kind of have to take them as they come. I just want to make sure you don't have that in your mind that it's always going to work. So as we hit examples, we'll talk about them. But, yeah, 2 more, please.
Does that mean like the -1/2 is like a diagonal asymptote kind of?
In a previous class, I believe they would have called this a slant asymptote. Does that sound familiar?
Yeah.
AP has never asked about slant asymptotes, so we just leave that for a previous class.
Okay.
2 more, please.
I'm just a slight bit confused. So a horizontal asymptote is like just a straight line that goes infinitely horizontally.
That's what we draw, but what horizontal asymptote means is the limit as x approaches infinity of the function is equal to a finite value. That's what horizontal asymptote means. So like in number 1 second, Caleb. In number 1, we have a function. We go find the limit as x approaches negative infinity. We discover that that limit is a finite value. Therefore, we declare that this function f has a left half horizontal asymptote. Now, when we draw that horizontal asymptote, we draw a horizontal line. But they're 2 separate things. What we draw and what a horizontal asymptote is are not the same.
Oh, so the y equals -1 would just be the y-intercept where the line is located.
This is declaring what is happening to the y-coordinates of a bunch of xy coordinates when the x-coordinates become extremely negative. That's all it's saying. It's not saying anything else. But we call that, somebody decided to give that a name. They call that asymptotic behavior.
So as x is closer to negative infinity, y is closer to -1.
They say that is a horizontal asymptote of y equal -1. That's just what they named it.
And in this case, it won't hit negative.
In this case, it actually doesn't touch in that example. But I can give you examples where it will touch a million infinite times, like it oscillates. It's an oscillation that does this. Now watch my finger. It goes up, it goes down, and it just gets smaller and smaller and smaller. So it's actually touching that horizontal line over and over and over again forever. But it is getting closer and closer to that horizontal line.
Is that what like the units are going to start to do that?
When you have periodic behavior, yes. Sine function, cosine function. It's all good. Electrical engineering.
Exactly understand all the word for it.
Good for now. Perfect. 2 more for Caleb. Feeling a little uncomfortable about that to me is very normal. Just kind of let it sit for now.
Okay.
Very good. Please.
So, I know it's probably not good to make assumptions, but if you look at the top and you see that x cubed is on top and x squared is on bottom, you can pretty much assume that it's going to be undefined asymptote, like not going to have an asymptote, right?
As long as you don't let them fool you with some other things they might write. So I never teach to do that. I always teach compare terms that add, factor and divide, you're safe.
Right.
Because I don't want you to step into a trap. A trap is that a well-designed problem that will try to use some trick students use and then they catch you. So your thinking isn't necessarily wrong, just it can be a little dangerous.
Right.
Okay. Any other questions on number 2? Yes, keep going.